This is a test of my first voiceover. What we're seeing here is uninstalling the existing Java development kit. If you already have one pre-installed, maybe of the wrong version, that's not Java 21, you can uninstall it here. That window is Windows add remove software control panel applet. So you would search for add remove in the Windows menu. What's going on now is a git bash window. That one's PowerShell, but we're wanting to bring up git bash, which is the main way that we're accessing command line Unix development tools like Git, and also to compile Java from the command line. And this is how we're going to run it with VS Code later. So we'll minimize it for now. You can see some leftover game things from Battle.net and Steam Autumn Sale. Pick up some of your favorite games if you have the desire. It's 40% off right now. Okay, so we're going to Battlecode's website, battlecode.org, and we're going to click on Enter 2025. Just a minute here, I'm going to go into a phone booth. So we want to scroll down to click on Quick Start, and the first step is to install a Java development kit. I know we just uninstalled one, so for this tutorial, I'm reinstalling back the same one. But for you, this could be the first time. And so this tutorial is for Windows. If you're using another operating system, obviously choose the tab for those. But here on Windows, we want the MSI installer. I think it stands for Microsoft Installer, MSI. It's a standard. It's an executable program. You download it. I already pre-downloaded it, so that's why it's so quick this time, but it could take you, a minute or two on your connection, depending on how fast it is. And when you double-click it in your downloads, you're going to walk through the installer like this. And as I mentioned before, the actual buttons and text might be different. Your mileage may vary on your computer, whether you're using Windows 11 or Windows 10. There's hundreds of different configuration options. So don't worry if yours doesn't look exactly the same, but try to understand what the steps are. So the step we're on right now is installing a Java development kit. Those are a list of tutorials for Java in general. They're good to dive into for later in the class, but we're not going to worry about them for now. Another thing you'll need is Git for Windows. So Git for Windows is a set of command line tools, namely Git, but also the bash shell, which is a command line interpreter to run processes and execute other tools like the build tool, Gradle, Java command line tool, Java C. And it comes standard on other operating systems. It's a Unix-like. It's like a Unix terminal. So this is the one for Windows, and it has its own path and standard Unix tools such as SSH or unzip or zip. So things that are not part of Windows PowerShell, or at least not without needing to edit the path variable and more detailed configuration than we want to handle. So Git bash handles all of that for us. The options are pretty small to read here, and for the most part, most of the defaults are okay. You can just accept them as you move and go on. We can discuss, unfortunately I can't really make out the text. The video is small, but when you're running, if you have questions about individual ones, let me see if I can actually, I can zoom it in. Okay, even better. So we're going to use VS Code, Visual Studio Code, as the editor. The reason I keep going back and forth is I'm thinking, I like Vim. It's how I learned computer science, but this learning curve is quite steep, so the warning they give you is pretty fair. And the main text editor, in our development environment, there are going to be multiple parts, and the main text editor we're going to be using is VS Code, so it only makes sense to use it for the merge editor too, which is when there's a merge conflict in Git, what default editor does it bring up for you to write a merge commit message, or even to view what the the actions of the merge are, and then to describe it with a merge commit message. And don't worry if you don't know what all those things mean, like merge conflicts, commit message. We'll practice those a lot. So here is, as I mentioned before, the path environment variable, and git bash will include its own tools and kind of assume that you're only going to be using git from within git bash in a command line way. And so we're going to commit Unix style endings on GitHub remote, but keep Windows style line endings on our own system. We're going a little bit fast now, but fast forward or merge, that's the default merge conflict strategy that we're going to be using. And the rest of it, we want to track symbolic links. We want, I forget even what the others were now, but we can go back and review them, but the defaults are okay. And go ahead and click next. You'll see that you're going to be installing git bash and its suite of Unix tools, some pretty essential glue stuff that maybe is not used or maintained actively elsewhere anymore, like Perl. Okay, and then we don't need to view the launch notes, but we're going to launch git bash now. And when it's launched, we want to pin it to the dock at the bottom so that you'll have ready access to it later. Okay, so now when it's brought up, we want to make sure that we can run Java. What version of Java is available to us, and it's Java 21, which is the one that we installed earlier. So that's working well and good. And then now we want to clone. So now we're going to test whether Git really is available to us on the command line. And I've already cloned it, so I'm going to move it to one side with the move command. And I'm going to put up subtitles of what I'm actually typing here so that you can follow along. But this next part will be git clone of the class repository. So this is the repository we'll be using for all 10 weeks of the class. I think I'm just examining what has changed since the last time. And it's just new versions of the game engine and the client number, so 3.1.0. Okay, I'm getting the remote URL. This is in the software setup instructions as well. But this is the clone URL, basically. This is how you pull a verifiable copy of the whole software. Remember we talked about how can you make sure you're running the same code as everyone else. So that's what Git repositories are useful for tracking, is all the files that are related together and then also what their latest version is. And so once you have it, you're going to change into the directory dgp-25au, change into Java, because that's the primary language of battle code, and then we're going to update with the Gradle build tool. We're going to clean all the previous artifacts, which includes the client and any class files from the player, and then we're going to build it again. And so now what we expect to see in the client is a file called battlecode client, and this is a Windows executable. So this is a new feature of a direct-to-native compilation that may have been part of the Gradle setup. That's not so important, but here is what the client looks like that you've seen in screen shares from previous classes. And you want to just play around and look at all the different tabs. So the runner tab is the one which lets us choose which players to pit against each other and which map to use. And then this is the console. So whenever it's like the debug console. So all the robots are little JVMs. They're going to print their messages to this console. And then the controls at the bottom, we should spend some time going backwards and forwards, restarting a match and slowing it down, replaying it to see who wins. But right now that's the reference player against itself, which is not so interesting. We want to develop our own player and pit it against the reference player. So now we're going to start on the development tools part of this tutorial. We're going to open VS Code, and there's going to be some fiddling here. Ignore, I'll tell you when to start paying attention to VS Code, but this is a setup that uses WSL, which is one way of running Unix tools on Windows. It is not the one that we are going to be using due to the fact that Battlecode is a graphical application, and it's actually not easy. It's not trivial to run graphical Unix applications from WSL, which is virtualized Linux. So we're going to switch to just native VS Code, and that means going back to the welcome window and opening a folder that's just on the normal native Windows hard drive, not inside WSL, which is like a sub file system. So yeah, we are going to load files from my home directory. My username is Paul P, but it's going to be whatever your username is on your computer. So sometimes there may be updates needed on VS Code. Don't worry if you don't get these error messages. My computer's hard drive is full, so I think I need to clean it up, or I cleaned it up after recording this tutorial. So now we're at the welcome window, and we're just going to open a file, and we're going to navigate to the DGP25AU folder, wherever you cloned it. I prefer in your home directory, and then in a parent directory called SRC, SRC, just stands for source. And then when you clone things, you just keep it all in source, and that's one way of organizing it. But if you clone it somewhere different, just navigate to that place. And then within DGP25AU, change into Java, which is a Gradle project. Go ahead and trust the authors. We are the authors of this source code. That kind of controls like whether some things automatically get run, like configuration files, when you enter this repository, which could be unsafe if they're arbitrary script files. So don't worry, you'll see and you'll make all the changes in this repository, and you'll be able to verify that they're safe. This is a Git repository, so it detects that, and if you click yes, now it shows that it tracks and it keeps the Git status of all these files. So the M tells you that those files are modified from the last time that anything was committed. And we'll talk more about that cycle, like what is a clean repository, what are modified files, and how to add, commit, and push them. But for your development environment, you'll want to accept its suggestion to install extension pack for Java. So if a window doesn't pop up suggesting you install it, you can click on the extension sidebar icon, the 4 blocks where one corner is like turned. That's the extension. You're going to search for extension pack for Java, and that's going to highlight Java keywords in your code. It's going to check for syntax errors. It's going to autocomplete members of variables and classes, all that good stuff that is part of a modern development environment. It's going to make developing Java a lot more intuitive and safe. So I recommend these extension packs. And then later, I don't know if we'll get to debugging, but debuggers in general are useful to have. So now you're going to open git bash terminal, and that's going to be one of the options in your plus icon. So down, in this integrated development environment, this has the text editor, file explorer on the left, and then the terminal on the bottom. You want to open up git bash as your terminal, because then it's going to give you access to Git and Java and Gradle on the command line, and all the things you expect with bash, like tab completion, and navigating the file system, cd, ls, the tools that you're used to that you may have learned in cybersecurity classes or other programming classes. Okay, so now we're able to explore these files, and we are opening up the main player code. It's called robotplayer.java, and what I'm going to do here is create from scratch a player called week01a. But this is something in the future that you're going to be able to do. For now, you can just rely on us in class creating this new folder, but I want you to understand what's happening. So in Java, the package name is matching the subdirectory of the source code. So there's a package called example funcs player. We're actually going to change that to be ref player because that's more accurate. So it's the reference player that we're trying to beat. And then every week we're going to come up with a new package, and we're going to copy and paste the old player. And so at the beginning, it's going to be exactly like the player that we copied from. So this week 01A robot player is going to be exactly the same as the reference player so far, and then now we are going to modify it, and we'll have practice doing this in class, and we'll take turns pair programming with a driver and a navigator. But we're going to vastly simplify it. We're going to delete a lot of the code. There are different unit types, mobile unit types like robot, mopper, splasher, and we're only going to have a mopper, and the mopper is not going to do anything so far except go around and explore. And then we're going to have stationary types, which are towers. And right now the tower, all it's going to do is create a robot, build one robot at the beginning. And there's an infinite while loop. So inside of the run method, because this robot player is basically a Java thread, and the way you enter a Java thread is through its run method. That's a standard part of the Java interface. If it were a standalone program, the main method would be the entry point, which is where it starts up when you run it from bash. But for a robot, run is the entry point. And there are things that run continually in the while loop, and most of the algorithms that we're going to be designing, we want them to be able to run continuously and then yield their clock time. So be able to run in steps to be resumable or yieldable, in other words. Like we want them to define a nice place for them to stop and then to pick up and continue the next bit of computation later. But before the while loop, because it's meant to run forever as long as the robot is alive, and if it ever exits the while loop and returns from the run method, then that robot self-destructs. That's just the rule of battle code, the way the game engine is designed. So before we enter the while loop, there could be some one-time things that we only want to run once. And one of those things is going to be, for a tower to create one robot, the first robot. So what I'm doing here is I'm rearranging the code. So depending on the robot type, if it's a tower, it's going to be creating a first robot, a splasher robot, a mopper robot at the beginning. And then inside of the while loop, it's going to be detecting whether it's a mopper or a tower and then running the correct function. So I'm going to get rid of these other secondary functions. So outside of run, you may want to organize your code by putting other behaviors into these methods. And they're going to be static methods at first. So run is a static method, which means it belongs to the class. It's not different for each object. And then the other methods, because they're called from a static method, also have to be static. So in battle code for these robots, they each run in their own JVM, and so each robot is like its own object anyway, and so the distinction of static and non-static is not so important, but because of the way the engine is designed, just expect things to use mostly static methods and static members. So here I'm just deleting the behaviors for soldiers and splashers, and even more complex behaviors for towers and moppers, just because we want to understand the battle code world piece by piece. And for this week 01A player, we are just going to be studying movement. We're going to change the package to match the directory name, which is week 01A. And we can't comment out all the cases and defaults in the switch statement, so I actually need to comment some of them back in. But yeah, this is the one-time code before we start the infinite while loop. If it's a mopper, we do nothing. Moppers don't have a startup action, but the default, which is the tower case, is going to create a first robot. And moppers and mobile robots can't create other robots anyway, only towers can. So in some sense, even if we had asked them all to create robots, only some of them can do it. And then now inside the while loop, we're going to try, we're going to uncomment out probably the mopper action, and then we're going to have a run mopper method that is going to, it's going to be empty for now, but what we're going to put into it is a spiral. It's going to cycle through all the directions it knows until it hits an obstacle, which could be the edge of the map, it could be a wall, it could be another robot, and then it's going to cycle through to the next direction. So what does it mean to cycle through? We'll go over that in a later lesson, but right now we're just going to have a run mopper action. And we need something that will throw a game action exception. So for mopper, case mopper, we're going to have a run mopper method, and we want to make sure that that takes a robot controller parameter, that's the RC, and then that it throws a game action exception, which we won't use for now, but we promise it in the function signature that it's possible it could throw a game action exception. And if it does, it'll print a message and then keep looping. So there's our function signature. Like we said, all functions have to be static for now because they're called from the entry point run method, which is static. And here's where later we're gonna cycle through all the directions. So for right now, run mopper does nothing. But this is, the to-do is traditionally in programming, that's how programmers tell each other we're to add more code in the future. Okay, so what we want to test is that we can choose week 01 A player in the player B, but since it didn't show up, new players are not detected, apparently, when you're running the client, so you have to exit the client and run it again. And you can run it from the command line in the client directory. I'm going to show you a different way to do it here, which is to navigate to the folder in Windows Explorer. So source, src, dgp, 25au, Java, and then the client directory. So it's good to have multiple ways of doing the same thing, because then it helps you. If you don't understand one way, you can understand the other. Or if you understand all the ways, then you can see essentially what's happening, which is that these are files located in a certain directory structure. So now we're able to choose week 01A, and you can see here the reference player is super active and the other player is apparently not doing anything, but that's because sometimes when we run the players, it skips over the initial action so quickly, and due to a current limitation, robots run out of paint and die after about 50 cycles. And so that's why in the previous run, it looked like no robots were produced at the end. But actually they were produced, 2 robots from our week 01A player, and then they just ran out of paint and died. And that's it. Any questions, please bring it up in class. Thanks for watching. Until next time.